and how to select the gravity disk using the nomogram in the subsequent minutes. And if you have not subscribed yet to the channel, please do subscribe, because this video is going to be very much helpful for the people appearing for the class 4 oral examinations. So let's proceed. Here you can see how a nomogram looks like. This is for the model SJ15H of the Mitsubishi Purifier. Okay, so we should know what all parameters are given on the nomogram chart. So let's focus here. You can see the separating temperature in degree centigrade and degree Fahrenheit at the x-axis. Also, you can witness the density or the specific gravity for this particular model going from 750 kg per meter cube to 1000 kg per meter cube. On the right side, you can see the inside diameter of the gravity disk in mm. Please note, it is the inside diameter and not the outside diameter. On the extreme right, you can find the feed rate of the purifier, that is in liters per hour. The feed rate is also known as the throughput of the purifier, and for this model SJ15H, it is from 500 to 4000 liters per hour. Also, you can see that there are some rising curves as well as there are some falling curves from the density, from the specific gravity side going to the right side. There are some rising as well as there are some falling curves, and how these rising and falling curves going to play in deciding the gravity disk size, we are going to discuss that. So far, the bottommost is separating temperature, the leftmost side is the density or the specific gravity. There are some rising and falling curves. There are the inside diameter of the gravity disk in mm, and on the extreme right you can find the feed rate in liters per hour. Please note that we are going to take the SJ35H purifier model for the plotting of the nomogram now. Okay, now taking the case 1. The case 1 says we know the specific gravity of treated oil at 15 degrees centigrade. Okay, from where this 15 degrees centigrade specific gravity we know, either we get it from the bunker delivery note during the bunker, or after our fuel oil analysis report. After the bunkering is done, we send the sample to the laboratory for testing. So from there we can get the density of the treated oil. So here, let's suppose we get 925 kg per meter cube at 15 degrees centigrade, which is standard. Okay, let's suppose we are going to treat this oil at 70 degrees centigrade, keeping the feed rate 3000 liters per hour. This is our treating condition. So now we are going to plot the nomogram and we are going to select the appropriate gravity disk. So let's see how do we select the gravity disk for this condition. This is the nomogram for the SJ35H model. Okay, so conditions are there that we have to plot at 925 density kg per meter cube. So I am marking a point here at 925. Okay, 925. Since I know the density at 15 degrees centigrade, I am going to use the falling curve for this case. If I am knowing the density at 15 degrees centigrade, then I will use the falling curve. So I have to plot line very carefully to the falling curve. Okay, now my separating temperature is 70 degrees centigrade. So I'm going to put the separating temperature 70 degrees centigrade here. Okay, so I'm going to plot a vertical line from there. Correct. So this is the intersection point. From this intersection point, I am going to draw a horizontal line straight to the extreme corner where the 100 degrees centigrade is there. Okay. So it has reached the 100 degree centigrade line here, correct? So now my throughput is 3000 liters per hour. All right. So I am going to plot a line reaching the 3000 liters per hour from this. All right. So what I am going to see, I can see here that the line is crossing the 78 uh, 78 mm inside diameter of the gravity disk. Okay, this is my 78. So I am going to use the gravity disk having inside diameter 78 mm for the conditions having 925 kg per meter cube with 70 degree separating temperature and the throughput of 3000 liters per hour. So I am going to get the 78 mm ID of the gravity disk. Okay, just now we have discussed the case of the specific gravity of the treated oil at 15 degrees centigrade. Now we are going to check the case number 2 where we know the specific gravity of the treated oil at certain temperature. It is not given at the 15 degrees centigrade, but it is given at certain temperature other than 15 degrees centigrade. Okay, now we are going to have the case where the density of the treated oil is given at 50 degrees centigrade. Let's suppose it can be 60, it can be 40. It is not compulsory that it is having always 50 degrees centigrade, but here we are checking, we are taking the case of oil treatment at 50 degrees centigrade given. Okay, at 944 kg per meter cube is the density given. Here the treating temperature is to be taken at 90 degree centigrade, keeping the feed rate 1250 liters per hour. So for these conditions, now we are going to check the appropriate gravity disk size for the purification. So let's start. In this case, first of all, plot the vertical line at 90 degree centigrade and at 50 degree centigrade. Okay, our density given is at 944, so it lies somewhat here, somewhere here, 944. Okay, so in this special case I'm going to first take the rising curve. So carefully trace the rising curve from 944 up to the 50 degree vertical line. From this intersection point, please take the falling curve up to 90 degree centigrade. Please ignore the inaccuracies because I'm using the digital pen here. Okay, this is the intersection point here. From this intersection point, please draw a horizontal line crossing the 100 degree vertical line. Okay, from this intersection point of the 100 degree mark, I have to keep my feed rate at 1250, correct? So at this intersection point, I'm going to reach my 1250 liters per hour feed rate somewhat here. Okay, okay, so if we are going to extend this uh, inside size of the gravity disk, so you can see here the gravity disk size comes out around 70.5 mm. Okay, so I'm going to take the gravity disk size around 70.5 mm for this condition at 944 kg per meter cube given at 50 degrees centigrade, but purification has to be at 90 degrees centigrade with my feed rate around 1250. Okay, so I'm going to get my 70.5 mm ID. So just now we have discussed the both cases, case 1 as well as the case 2, in which we got the 78 mm ID and the 70.5 mm ID of the gravity disk. Now if the question is there that we have got not we have not got the exact gravity disk size, Suppose we get the value 71 by nomogram, but we are not having 71. We have either 73 or 70. Then which one we are going to use? Either 70 or 73. In that case, always choose the higher gravity disk size. Why? Because in 70 there can be pure, highly pure oil you can get, but there may be loss of the oil going to the settling tank, the return oil. But in the 73 we can always play with the parameters, with the feed rate always, we can play with the operating temperatures. So this is how we can adjust the interface in order to get the purification done. Also, if we are having 71 and we want 73, let's suppose we are not having 73 but we have 71, then if the parameters adjustment is not uh, possible at all, in the worst case scenario, then we can also machine the inside diameter of the gravity disc with the lathe machine. Okay, suppose this is the 71 and we want 73, so carefully we have to machine the inside diameter to the 73. But this decision is at the last. If no adjustment of the parameters possible, then in this case we are going to machine the inside diameter of the gravity disc in order to get the proper purification of the oil. So I hope this video on the nomogram and the selection of the gravity disc by nomogram is properly understood by all of us. And please do subscribe to this channel if you have really understood the topic here. Thank you so much.